All right. Hello, advanced pre-calculus. Here comes our new set of notes, 7.4 through 7.6. And we start off with proving some trig identities. So we're going to give you some hints along here as we go. We've talked a little bit about this in previous notes, but now we're going to go to big time now. So when you prove you have to prove that the tangent of x plus the cotangent of x equals the secant of x cosecant of x. These are equal expressions, and you're asked to prove it. Same thing here. You're asked to prove that the sine of theta is actually equal to the secant of theta over the tan of theta plus the cotan of theta. The opposite over hypotenuse here can somehow be found by looking, simplifying all of this. So it's kind of a game. It's kind of fun. Actually, one of my favorite things when I was in your shoes that we had to do in math class. Okay, so some hints. Start with one side and make it match the other side. Usually you can work on one side. Sometimes you have to work on both sides to make them match. It just depends on how complicated the sides are. It's pretty simple, so I'm going to be able to work on one side here. It's pretty simple, so I'm going to just be able to work on one side here. On the other side of these notes, you'll see where you have to work on both sides. All right, so you must treat both sides independently of each other. You can't cross multiply. It's not like an equation. Okay, you kind of just have to work on the left side and work on the right side and see what you can get. All right. Simplify the more complicated side to match the other side. All right. Or, you might have to transform both sides of the identity to the same. All right, so this is this is working on one side. You simplify the more complicated side to match the other side, or transform both sides into the same expression. So this is working two sides, and either one's fine. And I'll show an example of each. Just don't cross multiply. Don't intermingle the sides, and you get yourself into a mess. Okay, so prove the following. One of the biggest hints, and we talked about this in class, is to express functions in terms of sine and cosine. These are your go-tos. Usually you can make some progress if you express everything in terms of sine and cosine. And, basically what combine terms on one side of the identity into a single expression. So, what I like to say here is when you combine terms, you're just doing the math. Do the math. So often here, just put a foot forward. Do the math. And then you can use, previously proven identities to simplify. So you'll see what I mean here in just a minute. So my first, I'm just going to go for it. I'm going to choose the left side. It's more complicated because it's two terms. Those that would count as more complicated. I'm going to write everything in terms of sine and cosine. So I've got sine over cosine is tangent, and then cotangent is cosine over sine. And I'm going to leave this side alone. And we just do a down arrow. Okay, so combine terms. So this is your do the math. Do the math here. So if you were going to do the math here, you would get an LCD. The LCD would be cosine x sine x. Okay, so you change the denominator by a sine of x, so change the numerator in the same fraction. So this is sine x quantity squared, which we write as sine squared x. We inflated this denominator by a cosine of x, so do the same to the numerator. You're just multiplying by a form of 1, which keeps everything legal. Okay, so hopefully you can see we have an identity here. When you go to the trouble of getting an LCD, leave it alone. start to see it proving. So this is a Pythagorean identity that is 1 over. Okay, that's 1 over cosine x sine of x. So when you have something like this, I can certainly split that when you multiply, not when you add, but when you multiply, I can split this into 1 over cosine of x times 1 over sine of x. Just think backwards. 1 times 1 is 1. Cosine of x sine of x is certainly cosine of x times sine of x. So I can split these like so when I'm multiplying. And what is the cosine of x? Well, that's the secant of x. And what is the sine of x? That's the cosecant of x. And that is matching the right side. And so we have proven the identity. Okay, so there you go. So recall our Pythagorean identity, sine of x squared plus cosine of x squared, quantity squared that is 1. You also have the tangent squared of x plus 1 is the secant. And you have 1 plus the cotangent squared of x is equal to the cosecant. So we're going to use those as well. Okay, so let's go to this one. So this is the more complicated side now, and I'm going to do the same thing. I'm going to just see where I can get if I write everything in terms of sine and cosine. Okay, so secant is 1 over cosine. Tan is sine over cosine. And cotangent is cosine or sine. Okay, so that looks a little complicated. So what am I thinking right now? Do the math. And if I had to do the math here, I would say I don't like these fractions. I'm going to get rid of these fractions. I'm going to use baby fractions. So I'm going to multiply by a form of 1. Anything over itself is 1. So that will not change value. That'll keep me mathematically sound. With baby fractions, you just choose the LCD of all the baby denominators. So I need the overall LCD of cosine, cosine, and sine. So the lowest thing that cosine, reset cosine, and sine would divide into, and that's going to be cosine of x, or cosine of theta times sine of theta. So I'm going to multiply by cosine of theta times sine of theta over cosine of theta, sine of theta. Really, you're multiplying by over 1 and over 1. That might help you align it better. Okay, so we're going to multiply the LCD of the little guys here to the numerator and the denominator. So when this multiplies in, the cosines cancel. Cosine cancels with cosine, and you just get sine of theta here. Okay, when this cancels in, it's going to distribute into the first term and to the second term. This is a group. This is a denominator. It's grouped. A fraction bar counts as a grouping symbol, so this is grouped, so I have to distribute. So when this distributes, the cosine will cancel, and you'll be left with sine of theta times sine of theta, which is sine squared of theta. You can see where this is going. And then when it distributes here, you can see the sines will cancel, and you'll be left with cosine theta times cosine theta, which is cosine squared of theta, which is a lovely Pythagorean identity of 1, and we have achieved our goal of turning the left side, or the right side into the left side. Okay, second one proven. Okay, so let's go down here. Here's another hint. Another hint. These are already in terms of sine and cosine, so this hint's not gonna work. It's already in terms of sine and cosine. So, what are we gonna do? Do the math. Not a lot of math to do here. So another hint is to multiply. These are very helpful. These are very helpful. So if you multiply by the conjugate, and to create a difference of squares, a difference of 2 squares, then you can use your Pythagorean identities. Okay, so let's just, these are equally complex, so let's just work on the left and turn it into the right. So the conjugate, do we know what the conjugate is? The conjugate has the middle sign alternates. So x plus 2, x minus 2, those are conjugates. So, usually we talk about it with a plus bi and a minus bi, but you can use that same vocabulary here, x plus 2, x minus 2, sine, 1 minus sine t, 1 plus sine t. So let's multiply this side by the conjugate. So again, I'm just multiplying by some form of 1, which is allowed because 1 does not affect multiplication. It's the multiplicative identity. All right, and let's see what happens. So up top, I'm just going to leave that alone for now because I like that 1. I like that 1 plus sign. I'm not going to distribute because I like that because it's matching. Maybe I can leave that alone and make it match here. So I don't want to feel compelled to distribute just because we did it 1,000 times in middle school. I'm going to hold off there and not distribute. Okay, cosine of t, and then this is going to be a difference of 2 squares, so I just have to f and l it. I don't have to do the OI because it will cancel, so f and l. 1 times 1 is 1 minus sine square root of t, and we see a Pythagorean identity. Woohoo! All right, so let's leave this alone. And, this isn't 1 outright, but if you just manipulate here, you can see that 1 minus sine, if I take this sine squared over 1 minus sine squared, is certainly equal to cosine squared. So let's make that replacement. Let's make that substitution. Okay, so cosine squared. And that's going to allow me to cancel a cosine. Okay, so that's going to allow me to cancel a cosine, which is great because if I can cancel a cosine, then I'm left with 1 plus sine of t over cosine. All right, so it feels a little bit like geometry with your proofs, kind of activating the same part of your brain there. All right, let's go to the back. What do we have? All right, so can you see that? No, okay, there we go. On this one, my first thought, would be, let's see what I can do on this side here. My first thought would be like, let's do the math. Let's just FOIL this and see what happens. Do the math. All right, so let's FOIL it. F would be cosecant of x times sine of x. There's f. Outer would be plus cosecant of x times 1. Inner would be minus sine of x. And last would be minus 1. So let's see if we can make any traction here. Well, these are reciprocals, so we got a nice cancellation there. 1 plus cosecant of x minus sine of x minus 1. Okay, that's additive inverses right there, so that's good. So let's maybe just write this as 1 over sine of x minus sine of x. And let's do the math. Okay, so let's get a LCD of sine of x, which will make this sine squared. So if you add a sine to the denominator, you got to bump the numerator up by a sine, so sine squared of x over sine. And look what we're going to get here. 1 minus sine squared of x over your LCD. This is simply cosine squared of x, which I can split as cosine and cosine over sine, and let's just do a little shift here. Cosine under there. We're multiplying, so this is all allowed. And, we can see that cosine is certainly equal to cosine. and cosine of x over sine of x is certainly cotangent, and I can just, commute those to match perfectly because I'm multiplying, and the commutative property of multiplication will hold here. So cosine of x times cotan of x equals cosine of x cotan of x. Boom. Okay, next one. Oh boy, both of these look pretty complicated. So I'm thinking this is a work on both sides. Yeah, this is going to be pretty tough to turn into this or this into this. So this is, I'm going to choose to work on both sides. Looks kind of fun though. Looks like I can make some headway. Got some ideas in my head. Cotan squared of u looks like a Pythagorean replacement. So that's going to come right here. Cotan squared of x is cosecant squared of x. So if I move that 1 over, I got cosecant squared of x minus 1. Let's try that. Okay, so cosecant squared of u minus 1. Okay, so do something over here in just a minute now. So here I see this is a difference of squares, and this is one of the factors of the difference of squares. So that's going to clear this up a little bit. I can factor this into cosecant of u plus 1, cosecant of u minus 1. Okay, so I did the commutative property of addition there and just wrote cosecant u in front and 1 at the bottom, so I can see this nice cancellation there. All right, I'm feeling like that's a good stopping point over here. Looks pretty simple. Let's see what we can do over here. So my thought is do the math. Let's do the math. Let's distribute. Okay, so cotangent times secant, and then minus cotangent times tangent. That's a reciprocal, so that's a good thing. It's going to cancel. 1. It's looking like a nice match. Let's see what we can do here. Let's do our sine and cosine hint. We write everything in terms of sine and cosine. Cotangent is going to be cosine of u over sine of u, and secant is going to be 1 over cosine of u. There's a cancellation there. And so I've got 1 over sine of u minus 1, which indeed is equal to the cosecant. And there you go. All right, welcome to Trig Identities. Don't get frustrated if you get stuck. Just keep on trying. Just try the hints I've mentioned, and if at first you don't succeed, try a different path. Also, if you're working with a partner, they may see a different avenue than you. It's perfectly fine. Somebody may have used the conjugate here and got it to work out. Totally fine. As long as you can get to the sides to equate, respecting your math rules, you're good. All right, folks. See you later. Have a good one.